Alright, this is one of the most classic binary search problems out there, searching in a rotated sorted array. Picture a sorted array that someone grabbed at some random point and twisted like rotating a dial. The key insight? Even after rotation, at least one half of the array around any midpoint is always perfectly sorted. And that's our ticket to maintaining O, log n. We just figure out which half is sorted, check if our target lives there, and eliminate the other half. We start with our classic binary search setup, left pointer at the beginning, right pointer at the end. Nothing fancy here, just standard bookkeeping. These two pointers will squeeze inward as we eliminate halves of the array, just like regular binary search. Here's our while loop, we keep going as long as left hasn't crossed right. And we calculate mid the standard way, integer division of left plus right divided by 2. This gives us the middle index to examine on each iteration. Super simple, right? First thing we check, did we land right on the target? If nums at mid equals our target, boom, we're done. Just return mid immediately. This is our happy path, and it's the same as any binary search. Now here's where it gets interesting, this is the rotation-aware logic. We check if nums at left is less than or equal to nums at mid. If it is, that means the left half from left to mid is perfectly sorted with no rotation break in it. Think of it like asking, is this side of the array still behaving normally? If yes, we can reason about it easily. Okay, so the left half is sorted. Now we ask, does our target fall within that sorted range? If target is greater than or equal to nums at left and strictly less than nums at mid, then it must be in this left half, so we move right to mid -1. Otherwise, the target must be on the other side, so we move left to mid +1. We can make this clean decision because this half is sorted. And this is the key insight, if the left half is not sorted, then the right half must be sorted. That's the beautiful guarantee of a rotated sorted array. The rotation break can only be in one half at a time. So we enter this else branch knowing mid to right is a nice, clean, ascending sequence. Same logic, just mirrored. If target is strictly greater than nums at mid and less than or equal to nums at right, it's gotta be in this sorted right half, move left up. Otherwise, it's hiding in the messy left side, so move right down. Watch how symmetric this is with the left half case, once you understand one, you understand both. If we exhaust the search space without finding the target, we return -1. Time complexity is O, log n, because we're cutting the search space in half every iteration, exactly what the problem demands. Space complexity is O, 1, just a few pointers. The takeaway? In a rotated sorted array, one half is always sorted, find it, check if your target's there, and eliminate the other half. That's the whole game.